Arithmetic is a reliable tool, but applying it to every number you encounter can be misleading. A calculation can be performed with perfect accuracy and still produce a result that has no meaning in the real world. Take a common scenario. Class A averages an 80 on a test, and Class B averages a 70. If we combine both classes into one group, is a total average of 75 automatically correct? The answer depends on the number of students in each class. If both groups have 10 students, 75 is accurate. But if Class A has 30 students and Class B has only 10, the larger group pulls the overall score closer to 80. In this case, we need a weighted average. We multiply each class score by its number of students, add those totals together, and then divide by the combined population. Class scores of 80 and 70 are summaries. To combine them, we first have to return to the base quantities those summaries represent. In the physical sciences, the add and divide reflex can be even more misleading. If you mix equal volumes of water, one at pH 4 and one at pH 6, averaging the labels to predict a pH 5 mixture fails to reflect the physical reality of the solution. A pH value is the negative base 10 logarithm of the hydrogen ion concentration. Translating these labels into actual concentrations reveals their true scale. A pH of 4 means a hydrogen ion concentration of 10 to the negative 4th. A pH of 6 means 10 to the negative 6th. Dividing these two values shows the disparity. The pH 4 solution contains exactly 100 times more hydrogen ions than the pH 6 solution. The simple integers of the pH scale hide a massive exponential difference in chemical concentration. Since we are mixing equal volumes, we must average the actual physical concentrations. Try it yourself. Pause here and find the true middle point between 10 to the negative 4th and 10 to the negative 6th. We convert the scientific notation to decimals and add them. Then we divide that total by 2. This yields an average concentration of 5.05 times 10 to the negative 5th. To find the label for our mixture, we apply the logarithmic formula again. The negative base 10 log of our new concentration results in a final pH of approximately 4.30. This makes physical sense. The concentration in the pH 4 bottle is so much higher that it overwhelms the ions from the pH 6 bottle, pulling the final mixture heavily toward the more acidic side. Averaging pH values correctly requires 3 steps. Convert to their base meanings, average those real amounts, and convert back to pH. This process reveals a broader mathematical relationship. Averaging the logarithms of two numbers is equivalent to finding the logarithm of their geometric mean. Compare 100 and 10,000. Their logarithms are 2 and 4, averaging to 3. Converting back gives 1,000, the geometric mean, not the arithmetic average of 5,050. 1,000 sits midway on a multiplicative scale. Each step multiplies by 10. To avoid meaningless calculations, always verify the context of the numbers. Ask, what does this number mean, and what would the average mean? Effective mathematics is the discipline of selecting the specific operation that accurately reflects the physical truth.